You are welcome to the tutorial number 2. In this tutorial we want to talk about the general purpose registers, the pointer and index registers, and the segment register, and also want to talk about other registers. So in 8086 or and the CPU, in the CPU there is four kind of register. First we have the general purpose. Next we have pointer and index register. We have segment register. We have other register, which are flag registers, and IP, which is the instruction pointer register. Okay. In order to master the assembly 886 language, you need to know all these kind of registers. We want to talk about each one of these in a specific way. And first thing, let's begin with the general purpose register, which is number 1. And number 1, we have the accumulator and the pace register. We have the count register. We have the data register. Okay, if you want to talk, if we want to take the first one, which is AX, we can group all these kind of register, A, B, C, D. A for the accumulator, which is used in we can accumulate data and put data in this register. Also, we can multiply the data in this register and divide the data, and also this register can be used for input and output operation. Next we move to the base. The base register is a pointer to the base address. We want to go in depth to the base address when we talk about the effective address. Count register. This is used for shifts and loops. And we have data, which is used for which is multiply, divide, and input output operation. And each of these general purpose register has two parts. So the length of this instruction is 16-bit. That means we have 2 byte. 2 byte. The first part is called the low byte, and the other one is the high byte. So for example, if we have the following number, let's say 8421 in hexadecimal. The first part will be here, so here we put 21, and the high byte will be 84. We put here 84. So this is a common division for the register. We have the low part and the high byte, and each one is consists of 8-bit. 8-bit. And also the same here as 8-bit. So this is shared among all these kind of registers. Accumulator, base, count, data has 2 parts, the high and the low. So for example, D has a DH and DL, and also CL, CH, CL, BH, BL, and AHDL. So this is for the general purpose register. Next, we want to move to the second type of register, which is special purpose register, and can be shown here, which is pointer and index register. In the pointer and index register, we have the following registers. We have the stack pointer, we have the base pointer, we have the source index, we have the destination index. And as explained in the figure here, we can see the pointer, stack pointer is pointer to the top of the stack, and base pointer points to the base index of the stack. And we have the source index and destination index. And notice that the SI and the DI are both used for the string operation of an operation, the operations on strings, and S for source and D for destination. And uh, these two registers are common used in the string operation for transferring string and in input and output operation. The third part, which can be categorized into the second part, and the third part, which is the segment register. This is one of the most important segments in the assembly, because this kind of register, these four registers, CS, DS, SS, and ES, are mostly used in the calculation of the effective address or physical address. So you take each one of these. For example, we take CS, multiply it by 10 hexadecimal, and then we add it for example, IP. So we got the effective address. The effective address is just use the code segment. And why we have an effective address? Because if you look to the assembly, uh, want to illustrate that, if you look to the memory in the assembly language, it consists of 20-bit address lines. So we have a 20 bit, we have a 20 location. So, but only notice that each register has 16 bit. So if you want to transfer in the memory, you cannot go to the location number 20. So to solve this kind of problem, we go with a segment register. So in order to get to the special location in the memory, suppose we want to go here, you take the segment register, multiply it by 10 hexa, and add that number to the IB, for example. Or maybe you can add the stack pointer, the segment of the source index, okay, which is SI, take ES sometimes, CS go with IP, DS, which is the data segment, go with PX, code segment go with IP, SS go with PB and SI, and also ES go with DI. So we wanna take other example on how to calculate uh, the effective address or the physical address in the memory given a code segment and given a register. How you can calculate. We wanna take other example to illustrate that operation. But for now, I just need you to know the basic registers, that we have 14 register in the 886 language. We have 14 register, and the segment register, which is our CS, DS, SS, and ES, which is used to in calculation of effective address. And also we have other register. With number 4, we have flags, and the flags, we have 16 flag. Each flag has 1 bit, maybe 0, maybe 1, and the changing in the flag is occurring when we do a mathematic or arithmetic operation on the register. The flag changed. And last one is one of the important register, which is IP, which is instruction pointer, which is mostly used in every operation you make in any fetch and execute in the execution cycle of a program. So I hope this is will benefit you. This is just a quick introduction on registers, but trust me, when we begin with writing code in assembly, those register functionality will be more clearly. So anyway, thank you for watching. See you in the next tutorial.